Hello everyone, welcome to the Digital Electronics class. In this presentation, we will try to find out the answer to the question what is a clock signal, because we cannot start a flip-flop until and unless we know about the clock. So let us try to find out what is a clock signal. We know that in a sequential circuit there are many processes going on. The output of a circuit is input of other, and thus there should be a control over the processes as they cannot operate randomly. So for that purpose we need clocking in order to time the circuit. In other words, we can say that we need a sequence of the circuit. It is called a clock because it decides the time of the input. We can also decide the speed of the circuit by changing the clock frequency. So what actually a clock is? A clock is a signal that goes from low to high, high to low, and then it repeats. It is a signal which has a duty cycle of 50%. So we can define a clock signal as a particular type of signal that oscillates between a high and a low state. The digital circuits rely on the clock signals to know when and how to execute the functions that are programmed. A clock signal is produced by a clock generator. Now we see that this is a clock pulse. From this figure we find that the clock is low here, that it is 0 here, and then it becomes high, that it becomes 1 here, and the time for which it is high is equal to the time for which it is low. Now again after becoming high, it again becomes low for the same time, and then it again becomes high and it again becomes low, and it repeats itself. Now let us suppose that the time period of this clock be capital T, and let small f be the frequency. Then frequency will be equal to 1 by time period, that is f is equal to 1 by t. Now if we want our clock to work faster, then we need to increase the frequency of this clock signal, or in other words we can say that we need to decrease the time period of the clock. Now let us suppose that we are giving this clock to the sequential circuit. Let us suppose that this is a sequential circuit, and let us assume that this is a SR flip-flop. So there will be two inputs S and R, and there will be two outputs Q and Q complement. Now we have given this clock as input to this flip-flop, and we have written it as CLK, which is the short form of the clock. Now this circuit or the SR flip-flop will work only when this clock is high. It means that this flip-flop will be functional for this time only, for this time only, for this time only, and for the next high pulse. In the same way, we can design the flip-flop to work when the clock goes from low to high. I mean that when the clock is here and it goes to high, then during this particular time, our flip-flop will be functional. Similarly, it will be functional for this low to high, for this low to high, and for this low to high, and so on. This is the leading edge and this is the falling edge. So we call this as edge triggering. Now we can also design the flip-flop to work when the clock pulse goes from high to low. So we can design a flip-flop in whatever manner we want. It may be designed to work for the high pulse, or from low to high pulse, or from high to low pulse. Hope this is clear to all of you. So we use a clock because we don't want our input to change randomly because for a particular input the output is the same and we want to use this output at a particular time. So we cannot let this output change randomly because there are so many processes, so many unwanted signals are coming in the circuit, and because of that our output may change. So the clock is the one which saves us from this condition. Now let us see what is a duty cycle. Duty cycle is most common term used in digital electronics. We can define duty cycle as the ratio of the time for which the signal is high to the total time. So if we see in this clock, we find that it is high for 50% of the time. So if T be the total time, then we find that it is high for 50% of the time, that is for T by 2. So duty cycle will be equal to small t by 2 divided by small t, and this comes out to be half, that is 50%. So the duty cycle for the clock is 50%. This is all about clock. Hope it is clear to all of you. See you in the next presentation.